Welcome to the Podkey summary of Build a Responsive Camera App that launches quickly from WWDC 2026. Today's roundup is really about one thing. Camera apps feel fast or slow based on a few very specific decisions. And the biggest one is whether people see that first preview frame right away. There's a clear theme running through all of this. Do the minimum needed to show the camera live, push everything else out of the way, and then keep the whole stack stable once real-world pressure kicks in. And on top of that, there are a couple of newer APIs that help with storage, hardware limits, and those moments when the phone is quietly telling you, hey, maybe ease up a little. The main takeaway on launch speed is surprisingly simple. What people notice most is how long it takes before the preview frame appears. UI can still be loading, buttons can still be settling in, but if the camera image shows up quickly, the app feels responsive. In testing, moving non-essential work until after that first preview frame cut launch time roughly in half, taking a startup that was close to a full second down to about half a second. That's a big difference in something as immediate as a camera, where half a second can feel like the moment already walked out of frame. A practical way to do that is to split launch resources into two buckets: critical for preview and everything that can wait. So you create the shutter button right away, because that's part of the core camera experience. But you hold off on heavier pieces like the image, and the mode picker until after preview is visible. That two-phase setup matters because it lightens the main thread during launch. If you try to build every view up front, you can end up with UI freezes right at the worst possible moment, which is exactly when the app is trying to convince the user it's quick. This is where Deferred Start comes in on iOS 26. It lets the app postpone initialization for capture outputs that aren't needed just to show preview. The idea is to keep the launch path short and unblock that first frame instead of making preview wait for the whole camera pipeline to be ready. The recommendation is to enable Deferred Start on every output except the preview layer. In the demo, they used a side-by-side LED timing test, and the device using Deferred Start captured the pattern earlier. So this wasn't just theoretical optimization theater. It showed up on camera, literally. There is one trade-off here. If the photo output is deferred, the time to the first actual capture is still long. So yes, the app looks fast because preview appears quickly, but the photo pipeline may not be fully ready the instant someone taps. That's why responsive capture matters. When is responsive capture enabled is turned on. The system adds a buffer so the app can still catch the moment even if that output is still spinning up. In the Domino demo, the difference was pretty blunt. The device with Deferred Start plus responsive capture got the falling dominoes, and the one without responsive capture missed the shot. For preview itself, there are really two paths with different priorities. AV Capture Video Preview Layer is the low-latency, hardware-accelerated option. It keeps CPU and GPU use low and is great when what you want is a fast, efficient live camera view. The catch is that you don't get per-frame access. If you need custom overlays, image processing, or metal-based work on every frame, AV Capture Video Data Output gives you that control. But once you go that route, you have to handle Deferred Start more manually if you still want the same launch time benefits. More flexibility, more responsibility, the ancient bargain. Another useful piece is the Hardware Cost API. It gives you a normalized value from 0 to 1 showing how much of the camera subsystem's bandwidth your configuration is using. And if it goes above 1, the setup isn't supported. That makes it a pretty clean reality check. If your format choices are too ambitious, the number tells you. And there are a few direct ways to bring that cost down. Choose lower resolution formats, reduce frame rates, or use bin sensor modes. Even if a configuration works at first, the phone can still start throttling under thermal or power pressure, and that's what system pressure state is for. If you monitor it, you can react in real time by dropping frame rate or scaling back GPU work before things turn into dropped frames and a choppy preview. The suggested pattern is to register a handler after committing the session, then adjust the session as conditions change. This is one of those quiet quality of experience details. Users usually don't know why an app stayed smooth, but they absolutely notice when it doesn't. There's also a very direct tool for reducing load: frame rate, overwrite. If you lower the active frame rate, say from 60 frames per second to 30, hardware cost drops with it. That means you can use frame rate as a pressure valve, especially when system pressure state starts warning that the current setup isn't going to stay comfortable. Used dynamically, it can keep the session under that 1.0 cost threshold and preserve smooth capture instead of letting the whole thing sag under stress. One more newer addition is AV Pro Video Storage in iOS 27. This is about recording reliability for heavy codecs like ProRes. It pre-allocates disk space, so writes stay deterministic even when the system is dealing with other I/O activity. Apps opt in by setting uses Pro Video Storage on AV's capture movie file, output, or an AV asset writer, and they need to check is Pro Video Storage supported before recording. It's the storage equivalent of setting the table before the guests arrive, which is a lot better than looking for plates while dinner is already happening. Finally, Deferred Start can be automatic or manual. On iOS 26 and later, automatic mode is the default, and the system usually initializes deferred outputs right after the first preview frame. Manual mode gives the app more control, which is useful if there's custom UI setup or preference loading you want to finish first, or if preview is being rendered through video data output. So, the automatic path is great when you want the system to handle the timing, and the manual path is there when your app's launch choreography is a little more specific. Put all of that together, and the pattern is pretty consistent. Show, preview, fast, defer what can wait, and keep adapting once hardware, thermals, and storage enter the conversation. A lot of camera performance comes down to timing, and in this case, the first thing people see really is the thing that counts most. And yes, sometimes the best way to make a camera feel faster is simply to stop asking it to do everything all at once. This episode was generated by Podkey. Create your own at podkey.fm.